Question A. Calculate the change in displacement over the first 3 seconds of motion.
You find displacement by finding the area in 3 seconds of motion and you add them together. So for the first 3 seconds, you have 3 seconds right here. You find that by finding the area of this. So it would be 3 times -1 because of your velocity and your time. So your displacement in the first 3 seconds is -3 centimeters.
Question B. Calculate the change in displacement over the entire 8 seconds of motion.
Like question A, you need to find the displacement for everything. So you would add up everything together. So for this one, we found -3. You have to find the displacement between 3 and 4 seconds, which would be 1 times negative, so it's -1/2. And then to make it easier in finding that, you can separate it so that it's a triangle and a square. So from 4 to 6 seconds, that's 2 times 2 divided by 1/2 would be 1. And this is 2 times 2, which equals 4. So you add up all your numbers together to find your total displacement. So you have -3 plus -1/2 plus 1 plus 4. It's 2?
Number
this
1.
is 2.
Explain why.
Oops.
Explain why.
This is 2 because you have 2 times 2 divided by 1/2. So instead of 1, that's 2. Which equals +2.5. So your total displacement is 2.5 because you're going, I'll explain it in a second.
Question C. Given that the cart starts with an initial position of +2.0 meters, plot the velocity versus time graph for this motion.
So we're starting with an initial position of 2 at 0 seconds. And then taking this, you find that your displacement is -3 for the first 3 seconds. So at 3 seconds, you need to be -3 centimeters farther away than what you were. So if you go down -3 centimeters for the first 3, because it tells us up here what it is, and then in 4 seconds, you move -1/2 from 3 to 4 seconds. So you go down a -1/2. And then from 4 to 6 seconds, you move up 2 in the positive direction. So travel up 2, so you're now at +1/2 at 6 seconds. And from 6 to 8, your total displacement is 4 centimeters. So from 1/2 all the way up to 8, you are at 4.5 centimeters. And then plotting that, the first section is constant because your velocity is staying the same, so you have a straight line. And then from 3 seconds to 6 seconds, your velocity is changing, so it's not the same, so you have a curved line. And then from 6 seconds to 8 seconds, it's constant again, so you have a straight line. Which is not very good. Okay.
Question D. Describe the motion of the object in words based on the velocity graph that you drew.
So based on the position graph that we drew, the object is moving backwards at a constant speed. So backwards at a constant speed. So
Should we ask questions?
and then it slows down, still going backwards because the change from that second is smaller. To find the acceleration, you're looking for the tangent line. So at 4 seconds, your tangent line is 0. It's horizontal, so it's 0. So you know that the object stops and then speeds up going forwards this time because it's in the positive direction. So object stops. And then for the last 2 seconds, you have a constant velocity again, but this time it's traveling forwards. So it's traveling forwards at a constant speed.
She's bragging. Yes, she is.
I thought we were like distributing something.
Christian.
And that's how you do stage start.
Thank you.